Still working on embedded assessment number 1 in unit 4. Vertigo round. We finished 1 and 2. So now we're going to be answering question number, I'm going to try to finish them, 3, 4, and 5. So question number 3 wants us to find the measure of angle AOX. I'm going to go over here. I've drawn I used the teacher's edition for to get this drawing right here. And then over here, I redrew the square, just drawing the diagonal AC, because that gives us quite a bit of information. If we draw a diagonal, we know that that diagonal is a line of symmetry, which means it creates two equal triangles. So that means that this angle right here must equal that angle right there if it is reflection, and same is true up here. Okay, now we also know that it's square, so all of these angles start off being 90 degrees, and if these two are the same size, then again these two angles right here must be the same size, so these must. So anyway, we figure out that this is a 45-degree angle. So this angle right here is 45 degrees. Okay, now why is that helpful? Well, if this angle is 45 degrees, okay, this angle right here, because it is a radius drawn to a point of tangency, you learned earlier in the chapter that that forms a 90-degree angle. So that means that this little triangle right here has to be a 45-degree triangle. Well, if that angle is 45 degrees, that is adjacent to this interior angle right here, which I believe is what we're looking for. So take 45 degrees away from 180, and I believe it comes out to be 135 degrees. So the measure of angle AOX is 135 degrees. Now the measure of angle OXA. OXA. We're looking for this angle right here. We've already found that one. That one was found in the previous problem. Remember that if we extend this on out, they told us that ZM was 53 degrees. Arc ZM was 53 degrees. And that angle that we're looking for, AXO, is the same angle as MXO or MXZ, however you want to look at it, and that has an intercepted arc of 53 degrees. So this angle right here, remember we had that as 26.5, I believe. This angle right here was 26.5. So 26.5 degrees was that angle. And then part C, I cut it off accidentally, says that CAX, so CAX, let me highlight it here. Let's go yellow. CAX. That has two arcs, okay? And I'll do those two arcs yellow. It has this arc right here, and it has this arc right here. We don't even have a point at these two sections, so we can't even name it. So I named them. I don't know if I should have or not, but I did. I called this point down here, I called this E, and then I called this point up here G. So I could talk about arc GM, and I could talk about arc EX. So I know that this is one of those where the angle is on the outside of the circle. So the angle is equal to half the sum of the arcs. Okay, and I have the measure of angle A. And you're going, no, we don't. Yeah, well, I haven't actually calculated it yet, but I can, because for triangle AOX, for that triangle, I have this angle, which is 135, and I have this angle, which is 26.5. Add them together, subtract them from 180, and we get this angle measure right here, which is 18.5. So I have the angle measure, 18.5 is equal to 1/2 of the arc, and we'll say arc EX plus GM. Now that's not quite enough yet for me to know what we can't calculate anything because I've got two unknowns, but I don't have two unknowns because go back to this angle right here. This is a central angle. It's 45 degrees, a 45-degree central angle. So the arc EX right here belongs to that central angle. So if that central angle is 45 degrees, then that arc right there is also 45 degrees. So here I have 18.5 is equal to 1/2. And EX is 45 plus, now GM, arc GM is the only, and it should be the measure, I should have the measure of arc GM, is my only unknown. So I'm going to multiply both sides by 2, and 18.5 times 2 is 37. So 37 is equal to 45 plus the measure of arc GM. Subtract, something's wrong, because if I subtract 45, oh, I see what's wrong. I added them. I'm using the wrong formula. My bad. I knew you couldn't get a negative number. So this should be, oh my goodness. That's what I get for not making good notes before I start. Okay, so this is going to be okay. All right, so let's try that again. So this will be big arc minus little arc. And big arc is 45 minus the measure of GM. So now let me go ahead and multiply both sides by 2. And 18.5 times 2 gives me 37. And then I have just 45. That leaves me 45 minus the measure of GM. So now when I subtract 45 from both sides, I get -8 is equal to negative measure of GM. So divide both sides by -1, and 8 is the measure of GM. So this arc right here, so GM, now we named it GM, the measure of GM is 8, and the measure of EX is, what did we say, 45. Okay, so we found those two answers. Now, you might just say the small arc is 8 degrees and the bigger arc is 45 degrees because we put the E and the G on there. Doesn't really matter that much, but because you're checking your own work. But it could be confusing if it was being graded by a third party. Okay, back to this one. So we found all of those. This one was 26.5, and this one was 8 and 45. And what was AOX? I don't remember. A 135. That one was 135. Okay, now we come down here and it says, okay, so we've got this picture right here. I kind of worked it out a little bit. So I drew in what they asked me for. And let's see, I can go to, I think, a new page. I think I got it right. No, I don't. It's okay, I can explain it. So what I did was I first said, okay, let's look at this shape right here. This shape, and I realized that sometimes you can't see that. So this shape right here, that's going to be horrible. EHGF is a square, so that means I have 90 degrees in this angle. So if I have that angle is 90 degrees, that angle that I have right there has two intercepted arcs. It has this one right here, which is SR. Okay, there's one arc. Remember, this is a 90-degree angle, so it has that arc right there. We can call that arc X. And then it has the rest of the circle, which is 360 minus X. So what I did was I set this 90, which was this angle measure right here, equal to 1/2 of the big arc, which is 360 minus X, minus the little arc, which was minus X. So 360 minus X simplifies to 360 minus 2X. I solved this and I got the measure of this arc right here to be 90 degrees. So I knew that it's going to be the same at every corner. So that one was 90 degrees, so that arc would be 90 degrees. This one was 90 degrees, so that arc would be 90 degrees. PS would also be 90 degrees. So that's how I got by with all of those being 90 degrees. Now I'm looking for, I think I'm looking for, what am I looking for? Find the angles formed by PS. And so I'm going to call this angle 1 right here, and I'm going to call this angle 2 because I've got to find all four of those angles. But these two are the same and these two are the same. So to find the measure of angle 1, I need arc SR, but then I need arc ZP. Okay, then to get the measure of arc ZP, I noticed that when they rotated this 45 degrees, and they tell us that they rotated it 45 degrees, A mapped to E, and B mapped to F, and C mapped to G, and D mapped to H. Okay, then Z, which was in the original picture, Z was in the original picture. I can scroll up here and show you. See, Z was in the original picture. And then Z mapped to, went this direction, Z mapped to P. Z mapped to P. So that means that that piece of the arc is 45 degrees because that's how much they rotated. So the arc from Z to P, since it's kind of like a tracing from Z to P, is 45 degrees. So, good grief, this picture's a mess. Let's see. I'm going to delete this, and it's going to delete a whole bunch of stuff. That's okay. I'm going to, this thing right here is 90. This thing right here is 45. So that means to find the measure of angle 1, the measure of angle 1 is equal to this arc, 1/2, 90 plus 45. And that means the measure of angle 1 is 1/2, 135, and half of 35 is what? The measure of angle 1 is equal to half of 35, half of 135, and that's 67.5. So the measure of angle 1 right here is 67.5. The measure of angle 2, is 180 minus 67.5 because angle 1 and angle 2 are complementary angle or supplementary angles. So 180 minus 67.5, and that leaves me 112.5. So angle 1, these two angles are 67.5 each, and these two angles are 112.5. Okay, for this last one, it says a circular stained glass and wrought iron window is to be installed above the front entrance. One of the stained glass windows design being considered has a radius of 90 centimeters and several wrought iron cords. Each of them are going to be 60 centimeters long. So we've got a radius that's 90, a cord that's 60. How far are the cords from the center of the circle? They've drawn a beautiful picture right here. So here is a radius. They drew that first radius right here, but that's not what they're calling X, because the radius, we already know the radius is 90. So they drew 2 radii. 1 to use as the hypotenuse of a right triangle, 2 to make sure that you have a right triangle. Because remember, you can draw a radius perpendicular to any chord, and what it does is it cuts that chord into 2 equal pieces, and it's perpendicular to it. So it told us that the chord, each one of the chords they were going to draw were going to be 60. So when I draw it perpendicular to a radius, I cut each piece and make it 30. So this piece is 30, as well as this piece right here being 30. So basically I have a 30, a side of a right triangle that's 30, and I have the hypotenuse that's 30. And so X is just the distance from here to here. This is the distance that they're asking for. So that's what they're wanting us to find. So you just use Pythagorean theorem. X squared plus 30 squared equals 90. This is a often used pictured scenario. And the problem is that when people say they got a radius, that first radius that they draw, they want that one to be 90. It is 90 centimeters, but the reason for having a radius and its full measure is so that we can use that as a hypotenuse. They forget to draw that other radius and then draw the chord perpendicular to that one. And the reason for that one is to form that right angle. And then we get to take that chord and cut it into 2 equal pieces. So the trick here is to remember you can draw more than one radius, and people don't. They just draw that one because, oh, that's 90. Now what do I do? And they just can't get past needing to draw another radius. So this is the Pythagorean theorem worked out. And so the distance from the center of a circle that has a 90 centimeter radius with 60 centimeter chords drawn, each one of them need to be 84.85 centimeters from the center. So measure 84 centimeters from the center, and that's where another chord can go. Measure 84 from the center, and that's where another chord can go. Measure 84.85 from the center, and that's where your chord can go. So that these measurements right here are all 84.85. And then these chords right here are all 60. This is 60. This one's 60. This one's 60. That's how you can make sure. Okay, I hope that helps. That's the end of embedded assessment number 1 of unit 4. Thank you for watching.